Alright, what's going on, guys? It's Mr. Creator here, also known as Bart, aka iOS Euphoria, aka Pwn to Owned. I can go on and on. Okay, so anyways, let's go back into our program that we were working on, which was Apple Controller, and let's see where we left off at. I believe we left off with detection and getting information from the actual device. So now we're going to be moving on to the next step, which is iDevice activation, sending requests to your own server, figuring out how to manipulate some information, how some old bypasses worked. Just try to cram as much iCloud stuff in this video, but at the same time, not dump too much on you. Just get you familiar with it, exposed, and have some sense of comfortability with working with iCloud and how some of these bypass tools worked. So let's just get straight into it. I'm going to try to explain as best I can from my perspective. That's what I always do. Let's go back into here, run the program, and let's see what happens. So I have my iPhone connected right now to it, and let's see. Alright, just like that. Super quick. And let's see. We did this without any timer or progress bar. So this is just instantly reading information, executing the entire function at once, and boom. If I disconnect it, there's nothing connected. Now if I connect it, perfect. There you go. Every time you see that flash, it means it's reading the information. Alright, so now what we want to do is figure out how some of this information can be passed into your own server. So let's just add this on. And I'm just going to show you a basic request because there's no API or anything that you can just quickly implement, bang, bang, boom. You are going to be writing all the code. You are going to be manipulating every single part of the code and changing it how you want, having full-fledged access to it. So we're going to do this. Ticket request. And this is not going to create a ticket and download it straight to your computer right away because that is a lot of work. We still have to implement some protocols, but I'm going to show you how it works. So basically when I click this button, it goes and executes this and writes it to a file. Read image first. All these comments will help you understand what's going on in the code. So what we want to do here is write the output after it executes. Okay, okay. Cool. Let's grab this. And now if I click on this ticket request, we're going to paste that here. We're going to say not iDevice info, but back in our project here, users. No, it's not in here. I actually saved it under this drive. Apple controller, bin, debug, net, lib. Okay, so we were executing iDevice info, but with this button for ticket request, we're not going to be doing iDevice info. We're looking for iDevice activation. So we can do the request using iDevice activation, and what iDevice activation basically is a tool for communicating with the iDevice activation system, basically, with communicating with the activation part on the iOS system and communicating with whatever server you put in. And if you don't put a custom server, it's going to, connect to Apple's default server. So here's some commands you can use with iDevice activation. iDevice activation, enter, will show you some commands you can run. You can do activate, enter, and see what happens. It's not showing anything, and then it says this iPhone is linked to an Apple ID. Enter, 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 enter. Alright, I had to escape out of that. So what that is doing is it's making a default request. So if you write iDevice activation activate, it's just going to make a normal request to Apple. But if you do iDevice activate -D, that's going to basically mean to log whatever information, debug any information So it's going to debug the communication with Apple. Alright, so there you go. So this is how iDeviceActivation works. It will be making requests by default to Apple if you don't specify any server. And we make a request. Let's scroll up. I want to just show you a little bit how this works. So here is the device making a request to the Apple server. So this is this right here is the information that is being passed from the iPhone. All of this information from here, from data, from collection blob, and you see data here, going down from data. You'll go down, 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 down to the end, copy it, and just open up a new browser to base64decode.com. Right? So base64.org, I mean, and paste your collection blob in this text box here at the top. So we want to decode what is this request that the device is sending to Apple. So this is the first part, and this is when it makes the handshake with the actual server. So before we get there, we have some information that's being requested to the server. Let's decode it, and let's take a look at it. Alright, we have ingest body, we have some data, and most of the time this data is base64 encoded or decoded, so that's why you can use this. So there you go, you have an Apple signature here, and then you have an Apple sig key, and then moving up, we also have the ingest body. So let's actually copy this and see if this will also decrypt. So we're going into the request of the actual device, decrypted some information, which is a collection blob. Then we're decrypting the ingest body. So let's see what's inside of that, if there is anything. Okay, copy. And there you go. Inside of the ingest body, you also have more information. So this activation ticket stuff and these signal tickets and all that stuff, it is not as easy as you may think, because it gets pretty deep and pretty complex. The hard part is finding glitches or some bugs that will work for you. So let's take a look at this here. We have the serial number inside of here, product type, we have the IMEI, we have an iOS version 15.8.2, we have the UDID, we have an MEID, and we have another part right here. Let's see how far this goes. I think this goes down all the way to here. So more information that's being requested, and I don't think this is something that can be decrypted. I think this is more of a key. So I'm gonna just give it a shot, but I doubt it. And I just want to show you how deep it gets inside of this file first. Nothing. Okay, that's what I thought. It's not gonna decrypt. So this is like some sort of encrypted key or a request or something along those lines. I'm not entirely sure. I don't want to give you false information, but yeah. So that's what I just wanted to show you, that it gets pretty deep when it makes that request. So there's that information. Inside of that, you have like an Apple SIG key, and the requests can all differ based on what device you have, what iOS version you have, what Apple chip it might have, what year it was released. All kinds of things can make the actual request, the activation request from the device, be different. So anyways, so there's that, just a little bit of information. There's a lot of information inside of a request. So let's see what happens. So then we have a connection with the server. We have the server KP, some blob, SUI info, a handshake response from the server. Just some information. Let's keep going here. Let's see what it's got. Okay. Post to the server. We post it to the server, and then we have more information. So this is what's being posted to the server, which is activation info. So this is content disposition. So this is the data that we're passing to the server. And to the server, there's a variable basically called activation-info. And for the server, for the variable information, activation info, we have this information. This is the information that's being posted to device services. So you can see this entire thing, which looks like a server. This looks like a ticket, but this is, let's see. I don't think this is a ticket though. Yeah, so look, let's copy this. Yeah, this is more of the request part. This is not the ticket. So this is more information that's being passed to the server. And it's being posted to device services. So let's paste this here, decode. So here is your actual wildcard request. This is your actual request for your actual activation ticket. This is just another, to me, from what I understand, this is just another request with blob information from the actual device. But I don't think the first part's what we want to be worried about. What you want to be worried about is the actual request to the server. So this is this information that we're telling the server. This information can be manipulated, like telling it like, oh, we have a different serial, we have a different iOS version, we have a different IMEI, MEID, or we can just say there is no MEID, there is no IMEI, and you can just play with the request however you want. Before I get into that, I just have to show you what is inside of the second request for the wildcard request, the actual ticket. In here we have the baseband the baseband master key hash, not mash, the baseband master key hash. We have the baseband serial number. Find my iPhone account exists, false. Activation state, unactivated. So this is basically all the information we are telling the server that we're connecting to. There's more information about this device. There's the MEID, there's the IMSI, there's the IMEI right here. There's the ICCID. A lot of information can be sent to the request, as well as the device cert request. This can be manipulated. The serial number can be manipulated. So here's all the information that's being sent to Apple. Okay, cool. What now? What can we do with this information, Bart? Well, I'm actually going to show you, because with ByteBurst, I'm actually showing you the code here. So these are the files that are on the server for ByteBurst, and here is this. Here's the file for ByteBurst. I'm literally showing you the code, how it works on my server. This is a paid tool, and I'm showing you the insides of how it all works. So when you get a request to my server here, let me show you something. If I go to iDevice, cancel this, enter. We want to do activate -s, and I'm going to show you basically this is how ByteBurst works. Curl. And the reason I'm going to tell you why we're using curl instead of iDevice activation is because this is a manipulated. You may not understand all of this code, but I'm going to try to fly through it a little bit. iDevice activation, when it makes that request, let me show you if I can just scroll through it real quick. There's so much information. Like here, this is where the request responds with, oh, this device is locked to someone, because this is what Apple replies with. Oh yeah, I think this is what the reply is actually. Okay, so when you make an iDevice activation request, oh my gosh, why is this so confusing to explain? Alright, here we go. So when you do something like this, iDevice activation activate -s, and then you put like your server, you want to put like a PHP at the end. So mine's is in ByteBurst activation.php, but this is most likely not going to work because of how the request is working. I can't even say that stupid fucking word. Let's see. Let me just find what I need really quick so I can perfect. Okay, so this would be a good example. Act request. This is a quick script that I made. So this will better explain to you what I'm trying to say. When you do ideviceactivation activate, and I'm gonna do ByteBurst this URL, we are connecting to my URL here. There's so much to go through. There is so much to go through. So when I connect to this, basically it just dies. Okay, that is okay. So basically it's saying this is PHP code. Activation, this variable is going to be connected to whatever variable we are passing in the request. In this kind of request, ideviceactivation, by default, it's passing this as the variable, and then inside of this variable is whatever blob information. So, I mean, let me just fucking hit enter and just stop explaining this. I'm trying to explain this. Oh my gosh. There's so much to go through, but I'm just gonna try to explain it as best I can. Why isn't this working? So stupid. So stupid. I don't know what the hell's going on, but it's pissing me off. I probably misspelled it. Yeah, I did misspell it. There was no E. Alright, so when I made this request, it'll just say activation server reports errors, because this is how it replied. So if I go into here, there's so much bouncing around I'm doing, it's pissing me off. So it creates a new folder. So let me just go through this file. It creates a folder right here. If there's a folder called tokens generated, which I'm in right here, tokens generated, inside of there it'll make a new folder, make the permissions read and write 777 whatever, and then inside of there you're going to put the activation response info, and then inside of that you're going to basically write a file to tokens generated, the serial number, and then the file will be called the serial number dash act dash rec.plist, and then inside of that we're going to write the information for activation. And this activation information comes from here, somewhere here, here. So we can make requests using ideviceactivation and this script. But for ByteBurst, this normal method, you have to use curl, and when you use curl, you have to define in the URL. For example, like this. If we're going to use curl to make the request to this PHP, you have to do question mark and then put sn equals 1 2. Okay. Okay. Stupid fucking keyboard. Sn equals, oh my gosh, dude, equals 1, and then you put and UCID equals 2 and UDID equals 3, and that is how you make requests to this. But let me just show you curl. So there's curl. Curl makes requests to PHP. Activation reports fucking errors, of course, you fucking piece of shit. Here we go. Bam. Look at that. So that is how you make a request to the activation. So using curl, this is how you make a request. Curl, euphoriatools.com, ByteBurst, activation.php, question mark, and then we're going to pass the variables, because in this is exactly what I've been trying to explain for the past 10-20 fucking minutes. Was passing this variable, and this is how you pass the variable over. So you can have a tool say your serial number is 1 2 3 4 5 6 7 8, and hit enter. Maybe I'm doing the request wrong. Hold on 1 second. I don't think it's and. Maybe it's question mark as well. I forget. I have to check my tool. There you go. Boom. So not and, but just put a question mark, question mark. So it goes like this. Um, curl space your URL where the PHP is on your server, and then at the end you put question mark, and then whatever, however your PHP says inside of here to pass the serial number. So it might not say SN, it might say serial number. You still have to put SN because it's getting get SN from the request, and this request is passing SN here. If you put serial number here, it's not going to work because the PHP is looking for SN, and then it assigns this information from whatever it got to this variable, and this variable gets streamlined basically across this entire program. So this is what gets shared. So if you are using serial number here, you would want to use serial number here. But if you're just going to use SN, then just use SN, you know. So just stick to that. And that is basically how you make a request. I will leave in the description, not the ByteBurst PHP, but I will leave the activation request PHP, because what this activation request PHP does is basically it will grab the activation info that's being passed from the device, and it will just save that simple request that devices do into a plist file, also known as the plist method. So basically, using this PHP, you can use it for your plist method if that ever comes to light again. But yeah, it will make the plist file here, here, and here. And so this is what is the plist file that people used to use for the plist method. And inside of here, it basically contains all the information about the device making the request. Um, so give me one sec. And so if I copy this information from this device's request, you can learn more about how the requests work, how the requests could look different between other devices, and so on. So I'm going to go back to here. We're going to close these because we don't need these open. But use base64decode.org, and this will help you decode and learn more about how tickets look like inside, investigate them, and stuff like that. So I'm going to go inside of here. So here it is. This is the request that we logged. We just logged it, and we decrypted it, and this is what it looks like from the phone that I have connected. Super simple. And this just basically helps you understand a little bit of how the iCloud stuff works. So what this helps you learn is that these devices all make their own request. They all have a special request that will have all the identifier information. Later on, I will explain to you how you can make your own requests and stuff like that, and make your own tickets, but not in today's video. In today's video, I had to explain just the basic information about the activation process and how some of the requests work for my server. Here's the PHP for ByteBurst as well, so I'm going to go through this a little bit and explain this as well. But I want to show you one more thing. So, another thing I wanted to just touch base in this video for you guys is explaining to you that for iOS 6 and all these different iOS versions, there's different ways of bypassing it. For iOS 6, all the way to iOS 11, I'm pretty sure, I'm 90% certain, 100% certain it works for all of these, but not too certain about these. I think it could still work though. So I'm going to actually separate these. With these, the old method was for bypassing iCloud was removing a file called setup.app. And setup.app is located in applications/setup.app. Removing this application would basically allow you to remove the iCloud lock, but you would have a battery drain because the device always has the baseband searching for a signal or baseband file, anything for a valid ticket. So the device is constantly searching and searching for information and services to make sure it's activated. Some services won't work, other services will. Using the setup.app method will not give you signal because there's another key step for it. In this video, I'm just going to be explaining bypassing iCloud. I'm not explaining how to get tickets for signal. That is a little more complex and a little more complicated compared to just doing a no signal bypass. So this is a no signal bypass, as well as for iOS 10 and 11 you can do the same thing. Sliver supports all the way up to iOS 14. So the method that they also use for iOS 12, 13, and 14 is a patched mobile activation D file. Mobile activation D is a process that is running in the iOS system, checking if the device is activated, factory activated, or unactivated. It does other processes as well, but I'm not 100% certain on it, so I won't be commenting too much on it. Although I do know that if you modify mobile activation D for iOS 12, 13, 14, 15, and 16, some 16 versions, um, you can modify these values that have factory activated, unactivated, and activated. You could swap these variables in this executable file, and next time you jailbreak a device and you injected that new mobile activation D, the device would have those variables swapped in the executable file, and so when it was running, it would just instantly think, "Oh, I'm activated," or "I'm factory activated," and it would just skip, and it would be factory activated, tethered. There was other patches for making it untethered, although it wasn't as stable. So they used for cellular devices, they would be using like a SIM pin or a SIM patch, um, stuff like that. There is also a tool called Black Worm Untethered. Let's see if I can find it, but I'm sure someone made a video on it. Alright, so here's someone that made a video on my tool. This is my old account, iOS Euphoria. Oh, I guess he doesn't even like use it. But anyways, yes, with this tool you would need to use a pin locked SIM card. That way it would just avoid checking if there's a baseband or something like that. It just glitches out the system to basically have an untethered iCloud unlock. Um, Nothing crazy, but I just wanted to explain that to you. Another thing I want to show you guys is, let's see. Here's more information on this iCloud stuff for you. So, here it is for iOS 12, for example. You guys can try this. On newer versions it might be different, or you might need to use a newer method. So here's how it works. First, they mount the actual file system. So when you connect into the device, you jailbreak it, then you SSH into it. The default username for every jailbroken device is root, and the default address is 127.0.0.1, or you can also say localhost. 127.0.0.1 and localhost are the same address. And why is it this address? Because when you are connected with a USB cable and then you use iProxy, what you're doing is you're establishing a bridge connection between the port 22 for SSH into the port 44, which is on the device that it's running. Um, Literally, it says it right here, is the masquerade port, and the 44 is the iDevice. So that's how you would connect into the device. This is what the device is running off of, and this is how you're going to bridge the connection between the computer and the device. So when you have iProxy running, you can then SSH. Once you SSH, you can run these commands to mount the file system. So you have to mount the actual iOS file system before you can modify like some directories. Once that is mounted, then you can unload and load daemons and stuff like that. This one removes the mobile activation D daemon. So this is the file that gets patched in, where was it? Here. So they had a modified mobile activation D that just says it's factory activated instead of activated, and the device would just be unlocked. It's pretty crazy, but pretty cool at the same time. So it removes that daemon. It, uh, does the UI cache, so it clears all the cache for any potential log files or uh, open files or running processes. From there, we have this is the path for mobile activation D, just so you know. Um, and then moving on, we change the permissions to 755 for this file, and then we reload it. Let's see how this file looks. I think this is actually the modified one. So I'm going to download this, and I'm going to show you how I work on these files. Just more information, giving you a better idea of how I look into this. And then right after I show you this real quick, I want to jump right back into the Apple controller and show you how to make the request to the PHP that I will leave in the description. It's only for getting the logged request. Again, I'm going to have more and more videos on this stuff, but I have to expose some basic information before diving deep into you know, the nitty-gritty development and how it all works and exploiting it and downloading it, and there's so much work into it. So I want to see, do I have this HXD? Perfect. So I'm going to open up HXD. This is a hex editing tool. This will allow me to hex edit information and recompile or not even just basically modify files, save them, and run them again and see if anything happens. So I went through this real quick, and you can see it looks like a bunch of gibberish in here. Like, what are we going to get out of this? If I type in activate, I typed in activate and I already have something. Failed to retrieve activation info, host connection, lockdown. This is very cool stuff. So this is a daemon that's running in the iOS file system. If we modify anything in this file and keep it the same file size and then upload it to the iOS device running iOS 12, it would most likely not notice any issues because the file size is the same. So if I delete, like, yeah, this changes the file size. You see that? Yes. And then I put 1, 2. Oh no, that's not what we want. Let's see if I put 1, 2, 3, 4. Boom. Now this is overwriting the information without changing the file size. But if I, you can see it's different. If you ever delete information, you're going to change the file size, and the file is most likely going to be considered corrupted by the system. So this is kind of a way you can hex edit files, modify things. I don't know, find a glitch in something. So if you modify something in this file, then you upload it to the system, then you upload a ticket, something might just work for you. It's about like finding what works, what doesn't, and then investigating the RAM disk. That's one of the best things you can do is actually download the RAM disk file or an IPSW of an iOS system, and then reverse engineering files inside of there, diving deep into like picture files or executable files, daemon files. You can do so much. So let's do another one. Activate again, activate again, activate again. This one's very cool. I found this a while back, but I don't know what exactly how this works. Here we have failed to create public key from data, lock, crypto, blah, blah, blah. Sequence failed to copy certificate, properties, label, unparsed, data. And then here you see data.appleinternal /lockdown.h activate h activate off dot enabled activation equals m dot disabled activation equals m equals 1 should hacktivate dot ifpga.com dot apple dot like boot args. So it looks like there's boot arguments that can be, I don't know if this is a file path for it, but it's very cool stuff. Like I said, here's a prime example that I'm literally going through it again and I'm like seeing it. iPod, iPad should activate. So I guess the activation option maybe would only work for iPods and iPads. It probably wouldn't work, and it has to use boot arguments for this. So the boot arguments would be, I don't know. maybe this is how it would be. Enable dash H activation equals dash MA equals 1. And then here's another one we see, disable H activation equals M1. I don't know, I would mess with this stuff. This stuff looks very cool. And I got sidetracked. Okay, moving on. Telephony should H activate internal. Wow, it's still going. Look at this. This is cool. Hacktivation is enabled, short circuiting, hacktivation state to activated. Very cool stuff right here. There's more certificates here. Keep going. And here is the part that I was talking to you guys about. So here you can see we have unactivate, activated, factory activated, and these are the 3 variables that if you swap around, you can actually save the file afterwards, and then the device will unlock. So here it says record.unlock.record, default record, wildcard record, care flag record. Yep. So yeah, this is the information that if you swapped it around like this, let's see. So now if I go into now watch this. If I did something like this, you can see the length is the same. Oh no. Actually, it's not. I probably copied a different symbol here. Yeah, it's probably not gonna. Oh, there we go. So if I paste it like that and save it, and it didn't say any file changes or changing or anything like that. So this would technically work, and it could glitch the system out and it would work. But again, there's an extra period here. I'm not a fan of that, and the file is saved, so I can't undo it. I would just re-download this file. It's some cool stuff to take a look at, but mobileactivationd, and if you re-upload this file, you could see some cool stuff happen, especially the older iOS versions. If you're just start playing with the older iOS versions. That way you could see the differences and stuff like that. Alright, so back to the program here. iDeviceActivation. So we want to just make a request to our server, ticket request, and it will just save the ticket request logged file on our server. We're not actually going to get a ticket request and get a ticket downloaded, because that again is more steps, more work. It's not something that I can just show you right away. I've already been recording for about 38 minutes, so you know it's already getting a little long. So let's go back into here. Ticket request. Ticket request. Okay, there we go. So we're doing iDevice activation, and then at the end we're going to not only execute that, but let's say executable path. Alright, so I'm going to copy this real quick, and I'm just going to say so all I said for ChatGPT was I pasted it and I said I want to add arguments to executable path. So here it is. And the arguments we want is activate dash D. So that means we're going to use activation, activate dash S space, and then put your server URL. So wherever you have this file saved. You can even use mine if you wanted to. I do not care. You guys can. Where is it? Give me 1 second here. Perfect. And we're gonna not do curl but ideviceactivation because by default it's passing that information. Activate dash S because we're saying activate on this server. Why isn't this working? Okay, let's copy this command. So this is the command you guys can also use if you wanted. All this is going to do is it's going to make a file on the server, and then later you can download the file, and I'll show you actually how right away. Just give me 1 sec. Alright, give me 1 sec. I'm gonna open one of my other tools so I can just grab my download tickets code. Okay. Alright, bam. So then after this does the request, assuming, so then it's gonna read the file, I guess. I don't know why, but we don't really need to log path. Oh yeah, so that's log act. So it's gonna read that file, and then here we're gonna say, not red's check, but we're gonna say and the file that's on my server that's gonna be created is gonna be tokens serial number file like this. So this is what it's gonna be called. Let's put that here just so we can see what we're working with. So here it's gonna be ByteBurst tokens generated, not .php because this is a folder, and then we're gonna say serial number let's see, plus serial, wait, what did we call the serial number in here? Alright, so we don't have a serial number, so we gotta add it. Serial number. Bam, bam, bam. You guys know the deal. You guys know the drill. Serial number text. Bam. Go here. Serial number text dot text. dot toString, put a plus, and then it's called dot plist. So at the end of the plus, because this is the variable, we're combining a variable with a string. Put a space because we can't combine that with that. Just follow along, you'll be okay. Downloaded ticket request.plist. So that's the file that we're going to call it, because this is just a ticket request logged file. So that's what it is. Alright, great. Almost done. And the last thing we need to do is add a serial. If product version. Alright, I don't know if this is actually going to work, but we'll give it a shot. Okay. As you can see, we are grabbing the wrong serial number. As I suspected, this bullshit would happen, and I will show you actually how to fix this. So let's go back into here and see what happens when I run cmd ideviceactivation. No, ideviceinfo, I'm sorry. So when I run ideviceInfo, how many times do we see serial number? We see it here, wireless serial number. Where else do we see it? Serial number. But this one has a new line, and then it has the serial number. So we're just grabbing anything that's the serial number, and then it has a space after it. This also has the same thing though. It has serial number and a space after it. So how can we set it apart? We can tell the system to look for a new line and then the serial number, because in here we have a secret hidden text box. Actually, not a hidden text box, but we have a hidden file called log. Log.txt. So this is what we're reading, and this is what it's looking for. So it's checking anything inside of here for serial number. And I'm like, okay, so where is it at? And we found it here. So we're going to just say look for environment.newline. Sorry, I keep getting notifications. Environment. Alright, let's see if that's going to work. Alright, so this is not working. Why? Okay, let's see. If line contains paste this here in ChatGPT. Alright, because this one has a space. And this one starts the index of here. If line contains... How many freaking serial numbers do we have? So we're just gonna... We can just tell it to avoid this. If it says this, then no. And we're gonna say and line dot contains let's put this back and see if that fixes it. Alright, and I think there's actually one more, but I just want to add it in just for safe measure. There's another serial number in here. Oh, there it is, baseband serial number. So this is another one we want to avoid. So we're just going to say paste that, copy this, and paste that. Oops. Go back into here and just also add baseband serial number to make sure it's not that. Alright, so that's how we're going to grab that serial number now. And now we can grab the serial from the device. Device. There we go, detected. Alright, now we're going to do the ticket response. Download the ticket, because that's actually what I want to do. Finish this up for this video. But make the ticket request. Give you guys the PHP to play with. You know, have some, you know, taste for how this iCloud stuff is working. And go from there. I would say start using iOS 12 and play with a modified mobile activation D. We'll also leave that in for you guys. Okay. So it could... Alright, so it executed this. Device activation. Oh, this is... The arguments cannot have that in there. Let's try this again. Oh, we can't make a ticket request without any data. Let's try that again. 0. How does this not have any data? Activate. I'll put a space in front of it just to be safe. Alright, so it looks like we wrote a file, but it didn't output what we wanted. So it looks like there's an extra space here at the end. Let's fix that. Alright, so I see what's going on. So this is making a txt plist file of whatever we're trying to execute. So what I want to do is I'm going to call this a bat file download ticket request.bat. This is going to be inside the bat as the command write that file and execute the file. So if I want to say write this file and execute it. So we need to just execute the bat file after it's written, and that's it basically. It's written, execute, bam, bam, bam. So we can't say process because we already have that being used up here, and this is inside of the parent, so we have to use process 2, process 2, process 2, process 2. Yes, you must do that or you're not going to be executing correctly. Rerun this. Go back here, close this, close this, close this, close this. Holy shit, how many fucking windows we have open. Detect. Got the serial number. Take a request. Made the file. Here's the file. I don't think it downloaded anything. Output to server. Okay. So there is actually no file called this, so we're just gonna call it output is gonna be downloaded ticket request.plist. Save. No, it doesn't even matter because we're writing that file every time, so we have to change it in here. We're gonna say create no window. Okay, I'm gonna say thread dot, oh my gosh, dot sleep one. Just a millisecond, wait 1 millisecond, please. That's basically what I'm saying. Alright, let's go back here. Boom. There it goes. It wrote the bat file, it executed the bat file, and then it downloaded the file from the server. And it says, oops, it looks like this page is lost. Start your website on the cheap. Alright, so it looks like I made a request, but the request was a failure, and it says that the file does not exist in the server. So let's see, where the fuck am I making this request? So to investigate, let's open up our bat file and see what it's doing. So it's saying to try to grab this file, right? So let's see if that even exists on the server or if I made a minor mistake. Okay, it looks like I did make a mistake. So let's go here, go to tokens. Tokens generated, this one. Here's the problem. Let's copy this and then look at the difference here. Where is the difference? Aha. So I have a whole nother serial as the folder that I'm going into. Alright, easy. So all I gotta do is do this. Now let's try this again. So maybe I was downloading the file from the wrong location. Let's see what happens now. You can also make your program automatically delete these. Every time you run your program, it could delete it, or every time it finishes running, it could delete those files. Okay. Oh, and look at that, 21 kilobytes, much bigger. Let's see if this is the correct file now. Bam. We made a ticket request to the server, and we downloaded the file from our server using curl. Very cool. So again, that's just some exposing to you guys, I guess, some information exposing you guys to the iCloud game, to the iCloud iDevice activation, how it works. Um, and if you're even gonna be ready to diving into this and, you know, getting your shit fucking set up for yourself to have your own tool or whatever you're gonna be building or exploiting or testing or what have you. But that's that. That is how it works. There are more files inside of here that you guys can modify and have fun with. I really don't care if you find it. Good shit. If you don't know, oh well. But that's the end of today's video. I hope you guys learned about how to make some ticket requests. And as you can see, it's 158, and now it's gonna say 159. There you go. Run the file, and you can open it with 3U tools as well, not just Notepad. Let's open it up. I hate when this shit just bugs out on me, but that's how I fix it. Just exit 3U tools and reopen it. Come on. Today would be great if I could just finish the video like this. Alright, well, whatever. So let me just open it with Notepad because that's something I can trust, or Visual Studio Code. And like I said, guys, you guys can decrypt this kind of information using a base64 decoding utility online, and then just, you know, manipulating it in the future and manipulating your request to Apple, creating your own PHP to be the man in the middle attack against the Apple device. So you can make a request, modify the request information on your server just like ByteBurst does, and then you will get a response for a valid ticket just like ByteBurst does without any IMEI or serial. It makes a request using an iPad identifier, and then when it gets that response, what we have to do is hide the baseband from the actual device, find the correct location for the files on that system, inject the activation record without any IMEI or MEID, and the device will activate without any serial. Without any IMEI or signal needed. It will have the IMEI, but it will not have any signal working on it, so the IMEI is useless. So that's that. That is what is iDevice activation and how some of it works. Again, it gets deeper. There's more information on it. There's so much more information on how requests can work and stuff like that. But again, I just wanted to expose you guys to it. So thank you guys so much for watching. I hope this video helped you learn a little bit more about how requests work. If you want to, I would just also recommend you guys check out these videos here. So I type in Apple Tech 752 archive, and you can find these videos online right here explaining you know, the iOS 13 through 12.4.8 iCloud bypass for free. So you guys can look at those tools, and I would recommend reversing his tools. If you can reverse his tools using a hex editor, I'm already giving you guys lots and lots of information, but I'm just saying, if you reverse his tools or anyone's tools, you will find some good information, and if you do find that information, keep it for yourself. That's all I'm gonna say. So that can help you learn. Looking at other created tools can also help you learn what you can do and what you should do if you are creating your own tool for the same iOS version. Again, thank you guys so much for watching. I hope this helps you out. I hope you guys check out these videos showing you how these bypasses work, and you know, doing it for your own tools or whatever have you. So thanks again for watching. I hope you guys check out the next video in the future, and any questions you have, just go to my Twitter and let me know what you want to what you want me to cover basically in the next episode, because I don't want to go into iOS 7 and showing you how to do the bypass, because if no one has an iOS 7 device, what's the point of me explaining it? I can explain and show you some of it, but I don't want to be demoing something you guys can't test yourself. So that's why I kind of wanted to stick around the iOS 12 versions. So again, thanks for watching, and I'll see you guys in the next one. Peace.